Hello everyone, myself Dhanush BS. I am pursuing my first year engineering in computer science and cybersecurity in Sri Venkateshwara College of Engineering. Today's topic is partial differentiation in mathematics. Introduction to partial differentiation. Partial differentiation is a mathematical concept used to find the rate at which a function changes with respect to one variable, while keeping all other variables constant. It is an essential tool in multivariable calculus, allowing us to analyze complex functions and their behavior in multiple dimensions. Partial differentiation is denoted by del and is used to differentiate with respect to a specific variable. So let's see about basic notation and definition. For a function of two variables, that is f of x, y, we use the notation del f by del x to represent the partial derivative of f with respect to x. The partial derivative measures the instantaneous rate of change of the function with respect to a specific variable while treating all other variables as constants. Mathematically, the partial derivative is defined as the limit of the difference quotient as the variable approaches 0. Computing partial derivatives. To compute a partial derivative, we treat all variables except the one of interest as constants and differentiate the function as usual. For example, to find del f by del x, we differentiate f of x, y with respect to x while considering y as a constant. The resulting expression represents the rate at which the function changes with respect to x while keeping y constant. Higher order partial derivatives. Just like ordinary derivatives, partial derivatives can be taken multiple times to obtain higher order partial derivatives. For a function of two variables, the second partial derivatives can be denoted as del square f by del x square, del square f by del y square, or del square f by del x del y and del square f by del y del x. The second partial derivatives provide insights into the curvature and behavior of the function in the different directions. Mixed partial derivatives. Mixed partial derivatives are obtained by taking partial derivative with respect to one variable first and then with respect to the other. There are two possible orders of mixed partial derivatives, that is del square f by del x del y and del square f by del y del x. In general, the order of differentiation may affect the outcome, and the quality of mixed partial derivatives depends on the smoothness of the function. Partial differential equations. Partial differentiation is crucial in the study of partial differential equations. PDEs involve functions of multiple variables as their partial derivatives, and they describe many physical phenomena. By applying partial differentiation techniques, we can solve PDEs and understand the behavior of systems in various fields such as physics, engineering, and finance. Applications of partial differentiation in physics. Partial differentiation is extensively used in physics to analyze and model complex systems. For example, in fluid dynamics, partial differentiation helps describe the flow of fluids and the distribution of quantities like pressure and velocity. Similarly, in electromagnetism, partial differentiation is employed to understand the behavior of electric and magnetic fields. Applications of partial derivatives in economics. Partial differentiation is also applied in economics to analyze functions that involve multiple variables such as production, cost, and utility functions. By differentiating these functions with respect to specific variables, economics can determine the impact of changes in variables on the overall outcome. Partial differentiation helps in optimizing decisions and understanding the interrelationship between different economic factors. Applications of partial differential equations in engineering. In engineering, partial differentiation is utilized to analyze and optimize complex systems such as heat transfer, structural mechanism, and control systems. By taking partial derivatives, engineers can calculate rate of change, determine critical points, and optimize designs. This mathematical tool enables engineers to make informed decisions and improve the efficiency and performance of various engineering systems. Practical examples of partial differentiation. A practical example of partial differentiation is finding the gradient of a function which represents the direction of the steepest increase. Another example is determining the critical point of a function where the partial derivatives are equal to 0, representing potential external. Partial differentiation is also used in optimization problems